Welcome back to the last session of today of the USC AI Futures Symposium. I want to introduce the chair of this session, which is a panel, Kristina Lerman. She's been introduced before, but she's a research professor of computer science and a principal scientist at the Information Sciences Institute at USC. Kristina?
All right, thank you, Yolanda. All right, so we have been talking all day already about various issues, and I know lots of things came up in the conversation before, in the Q&A sessions before, but we wanted to bring in some leading experts in this field to help us kind of guide our thinking about how we should think about AI agents, issues of AI agency, legal aspects, ethics, responsibility, what it all means. And so, we have invited 3 leading experts in this field. Unfortunately, just in the last minute, Oren Etzioni is not going to be able to make it. He had a medical emergency, unfortunately, so we wish him best of luck to recover. But we will have, we will make our best, do our best with Patrick Lin and Cynthia Rudin. I'm very excited and happy to have them here. So Patrick is a director, he's a philosopher by training and practice, and he's a director of ethics and emerging sciences group at Poly, and he has been thinking about AI ethics, robot ethics for over a decade now. So he has many valuable perspectives to offer in this. And Cynthia Rudin is a professor of computer science, electrical and computer engineering at Duke University, and also physical science. And she's also been very active in this field of AI fairness. And when I reached out to the panelists initially, I asked them to think about these questions, that humans bestow trust carefully to other humans, but rarely to AI systems in matters of importance. What research needs to be done to improve trustworthiness in AI systems? What are the factors that influence how people decide to trust AI systems? What are the limits of purely algorithmic solutions? How should we approach the design of trustworthy AI systems? So these are the questions they were thinking about. And the format of this panel will be, the panels will have some time to give their position, present their position on these questions. And then we are going to open it for more broad discussions, and audience members, you can feel free to type your questions in the Q&A box, and I will read them out. And we'll proceed like that. Okay, so just a second. So stop sharing, right? Oh, no, stop sharing. And Patrick, could you go first, Patrick?
Sure. Okay. Hi, everybody. So thank you, Kristina. Thank you, Yolanda, and others at USC for organizing this great symposium. So today, I just want to offer some reflections on what it means to trust, and in particular, what it means to trust AI. I think I'll slip the slide since I've already been introduced. So to unpack what it means to trust something, let me start with the work of Honora O'Neill. She's a professor at Cambridge, and she's known for doing some of the best work on philosophy of trust. So she identifies 3 key factors in determining trustworthiness: whether someone or something is competent, honest, and reliable. Okay, so I'm going to apply that framework to AI here, which means asking, can AI perform the task needed? Can it explain its actions and decisions? Can we count on it to work as advertised? And to understand what these requirements mean, let me first make sure we're on the same page with some basic examples of trust. So think about, for instance, your dog who you trust to be nice, or your kid who you trust to stay on top of school, or you trust a team member to wrap up and submit a report. Okay, so the first thing I want to note is that trust seems to be application specific. So here are some examples where you wouldn't trust the same agents from the last slide. So maybe you can't trust your dog to not chase after people, or you wouldn't want to trust a kid to manage all your money, right? Or you wouldn't trust your AI or philosophy colleague to do major surgery on you. Right? So this means it's appropriate to have different standards of trust depending on the context, background assumptions, and other variables. So let me give you a couple examples here. So number one, it's probably not enough to run an AI driver through the same 40-minute driving test that humans take, right? We're much more familiar with humans and our own capabilities, and especially our own limits. Or think about an Office app that's reliable 99% of the time, right? So I mean, our Office apps still crash every now and then, but not a big deal. But that's probably not enough for, say, autonomous cars, since that means an average of 1 error every 100 seconds, which could be fatal at highway speeds. So back to Honora O'Neill, a related point in her analysis is that reliability isn't enough for trust. They're not really synonymous. So for instance, it seems weird to say that you trust your pen to work, or that you trust gravity to keep you on the ground, as opposed to merely relying on these things. So to trust those things, that seems to be a category mistake, right? To trust things that aren't agents, especially if competency and honesty are also needed for trust. So the question here is, can AIs be agents? And we don't have to, we could shelve that conversation or table it for now and just say, look, maybe they could be agents, as long as AI is more than a glorified flowchart with some predetermined outcomes. But for ordinary stuff, it just seems metaphorical or anthropomorphic at best to say you trust them, right? Or if our trust in an object is really a proxy trust in its creator, that's still metaphorical, and the creator's reputation then becomes super important. On the honesty requirement, there are two senses of honesty that we should recognize. One is a negative sense. Honesty means not to do certain things, such as not to lie. But another is a positive sense, right? So honesty also means acting in certain ways, such as telling the whole truth. As it applies to AI, this seems to mean that an AI system needs to be able to account for its actions and decisions. Or in other words, it needs to be able to explain itself, or its decision-making process needs to be transparent. Finally, let me note the connection between trust and accountability. Trust can help to establish responsibility and liability, and these things are important for public confidence and market adoption. But we really need to be careful here, because we can misplace our trust in either direction. We can over-trust something which should not have been trusted in the first place, or we can under-trust something and fail to get all the benefits of using them, including life-saving benefits. So think about, for instance, vaccines today that many people don't trust. Well, they have under-trust too. So this is all to say that it's vital to have conceptual clarity on what it means to trust something. And I hope I teased out some of the nuances in exploring this concept. So that's it. Thanks. And I look forward to this panel discussion.
All right. Thank you, Patrick. Can you stop sharing your screen?
Yes.
So let me go back. And now we're going to have perspective from, oops, I should have advanced. Perspective from computer scientists. All right.
Okay, I think you need to enable my video in order for it to start.
Enable your video?
Yeah, there we go. Good,
okay.
Thank you. Okay, I only have 4 slides. Okay, so I'm going to talk about interpretability and how it and how there's a false dichotomy that revolves around interpretability, and a lot of even machine learning researchers kind of get this messed up. Okay, so can you advance? Thanks. So I'm just going to tell you this dichotomy. This is a question that was posed by the organizers of the Explainable Machine Learning Challenge from 2018. This was a challenge that was organized by NIRIPS and FICO. So the organizer, so they gave all the competitors in this competition a data set, and they said, create a black box for it and explain it. Right? That was the competition. So they gave us this dichotomy when they were presenting the results of the competition. They said, okay, you need surgery. You have cancer, you need surgery. And there is there's a black box, and it's quite accurate. In fact, if you get the black box, there's only a 2% chance that you will die getting your surgery. Versus if you have a human doctor, You have a 15%, you can ask the doctor anything. The doctor will tell you anything you want to know about the procedure and so on and so forth. But if you get the doctor, there's a 15% chance that you won't survive. Okay, so which one would you pick? And then they ask the audience, and the audience all raise their hand for the black box, except for me. And so the question is, well, you know, what actually happened here? Is this, what's going on? And I claim that this is a false dichotomy. Can you advance? Okay, so thanks. So yeah, so my question is, why must the robot actually be a black box? Are people going to design robots that are a black box? Because right now our robot designers they actually know what the robots actually do. So the question is, would the robot lose its ability to perform accurate surgery if it was enabled with an ability to explain itself? Would the robot actually become less accurate if you enabled it to be able to explain what's going on? Wouldn't having better communication between the robot and the patient or a doctor improve patient care rather than diminish it? Like, who's gonna tell the doctor that, maybe you have some rare blood clotting disorder and that you actually might need the doctor to know about that in order to take care of you better? Okay. And then also, so would the patient need to be able to explain to the robot that they had some sort of weird condition before the surgery? Okay, so what if the patient is unusual and didn't explain that to the doctor? So machine learning algorithms are really great about performing well in the domain that they're trained on. But the truth is that if you go even slightly outside of the domain, then they don't perform well. So the nice thing about a human is that it seems to be a little bit more adaptable and can say like, oh, okay, this is not what the algorithm is trained for. I need to change something. Like, oh, there's a pandemic that's happened. I need to sort of, do something different. And then also the 2 and 15%, that's really strange. So where did they get those numbers? Because those numbers would normally come from a data set, but every large medical data set I've ever seen is confounded. So maybe it's possible that the robot got the easier patients and the human got the harder patients. And the human doctor is actually much better, much more accurate than the robot. It's just that they got different patients. And so this level of confounding can actually mess things up. And you can ask also whether there are flaws in the data set. Like I said, I've never seen a large data set that's actually not seriously noisy. Okay, so next. Yeah, so, and then there's also the matter of typographical errors. What if someone entered my data wrong into the robot and the robot didn't actually know who I was? And so I actually might get worse care because I can't actually tell the robot that I'm actually who I am. Okay, next. Now in machine learning, evidence does not support an accuracy interpretability trade-off. I've tried to find one. I've worked in sort of so many different domains. I've tried my hardest to find one, but have not found one. Even in computer vision, even in deep learning for computer vision, there are interpretable machine learning models that are just as accurate as black box machine learning models. And it's not just me who's found those. There are many, many different groups right now working in computer vision where the deepest of the deep neural networks are sort of king. Now for the FICO competition, where they introduced this dichotomy, the instructions were to create a black box and explain it. We didn't do that. We simply created a model that was interpretable because the data set was amenable to having an interpretable model, and we didn't need a black box. Now, in machine learning, it's generally dangerous to trust a model that you don't understand because, again, you're trusting a data set, and I don't trust big data sets, right? There's always something wrong with them, there's many other reasons why you wouldn't want to trust a model that you don't understand. That's a machine learning model specifically built on data. I mean, there's a lot of things you can trust, right? You can trust a formula, right? Just like if, your computer, you trust it every day to log into Zoom and it's just following some deterministic path. But when it's data and randomness and the data has to be trained in a certain, the model has to be trained in data from a certain distribution and so on, that's when you start thinking that maybe you shouldn't trust it. Okay. That's it. Thank you.
Oh, thank you, Cynthia. That was actually, it relates, I don't know if you got the chance to see my slides, my talk. I was talking about biases in data and how they can confound and they can actually affect the conclusions of the models. So that actually fits right into what I believe as well. And I like this perspective that it's actually, It's not about trusting the algorithms, it's about trusting the data. So, okay, we have one question ready, but maybe I'm going to start it off with some of the other questions. So first, my own questions, I'm going to start off. First, I'd like to play kind of a devil's advocate and ask both panelists and others in the audience as well, why do these questions apply to AI only? Oh, sorry, I'll start my video. Do we hold AI to a higher standard? Shouldn't this be the question actually that should apply to all the other technologies that we have? Why AI specifically and machine learning?
I could take a first stab at this. I think as I alluded to in my talk, it might be a category mistake to apply trust to AI. So Kristina, maybe this is where you're getting at. It does seem weird at the outset that, well, why are we asking about trust in AI when we're not asking about trust in hammers or trust in guns or trust in, water?
Or trust in cell phones or trust in GPS. Yeah.
So, I mean, one answer might be, well, look, we're just being metaphorical, or we're anthropomorphizing AI to think that it's more of an agent than it really is. Now, in my talk, I actually left open the possibility that, yeah, maybe some AI really are agents, right? They're not deterministic. In which case, that might be a reason to raise the issue of trust with AI, because they appear to be agents, right? Maybe not full-fledged agents like a grown-up, but certainly, like a pet, an animal, or a small kid, they have some agency, which implies some responsibility. Yeah, just a quick stab at the answer.
Mm-hmm. And Cynthia, certainly AI is not the first one to deal with large data sets. So is there something special about AI algorithms that make the reliance of data more problematic for trust?
Yeah, I'm not sure exactly how to answer this, because you would also apply that question to statistical models. You'd say, do I trust that statistical model? Because there's something about generalizing out of sample that you would associate the word trust with. It's like, you haven't seen that particular observation before. Do I trust you to make a good prediction from it? So there's something about that randomness, that generalization that somehow makes you associate the word trust with it. But I haven't sort of, I've had only less than a minute to sort of figure out what the right answer is, and I don't think I've gotten it quite yet.
All right. I'm going to intersperse with some questions from the audience. So kind of building up, first I'll ask a question by Jerry Hobbs. It says, I trust Turbotax. Is Turbotax an agent? Building up on your comments, Patrick.
Is Turbotax an agent? I mean, in one sense, it's a financial agent of sorts, right? That you've you delegated some of your authority or responsibility to correctly processing your taxes. But I wouldn't say it's a moral agent or an agent in the sense of a person, because Turbotax is deterministic. If you plug in the same numbers for the same fields, every single time it'll give you the same results, right? So there's really no agency. It makes as much sense as saying that a thermostat or a watch is an agent. I would think.
Well, alternatively, we could introduce a stochastic component in Turbotax, but that alone would not make it an agent. So.
Well, machine learning models are deterministic, but the machine learning models are trained from random data, whereas Turbotax is not. It's just a bunch of formulas. So in that sense, there's no question of trust. It's like, yep, it's just a formula. We're just applying the formula, fine.
Right. So I would say the proper term is more like about reliability. Do I, is it reliable? Is it accurate? But trust, again, I think is connotes some things that we need to be careful about, because if we start applying this question of trust in everything that looks like a computer, then again, I think you're going to risk anthropomorphizing the issue. And when you do that, you run into some dangerous conclusions about what AI should or should not be doing once you start anthropomorphizing them.
Okay. there's a question from Henry Lieberman. What about the issue of value alignment? An AI agent could be competent, honest, transparent, etc. But if its goals are misaligned with the humans, it's not good and you should not trust it. We've got that problem now where agents are supposed to be helping you, giving you recommendations, are also working for organizations that may have ulterior motives not aligned with yours. Anybody want to take a stab at this? I think Patrick has waved you on, Cynthia.
I'm happy to do it, but I just want to make sure I give Cynthia a chance to, to jump in.
Oh, I'm perfectly happy if you want to answer all the non-machine learning questions.
Okay. Yeah, so I know value alignment is this big issue in certain fields, certain sectors of the AI machine learning community. I just want to point out, though, that value alignment is not the end all be all. All right, it doesn't solve all these problems. So for instance, let me back up. So the value alignment problem is something like this. I mean, if you think of, you remember the Walt Disney movie Fantasia, and there's a clip about the sorcerer's apprentice. Mickey Mouse is the sorcerer's apprentice, and he doesn't want to do the chores of lugging water from the well and dumping it. So he steals his master's hat, the wizard's hat, and he enchants a broomstick to do his chores. The problem is the broomstick has no common sense. Its values are not aligned with Mickey Mouse's, right? So it doesn't know when to stop. It doesn't know what it's doing. It doesn't know, yeah, you shouldn't be flooding the house. So that's an example, like a textbook example of misaligned values, and you can see where that can cause problems. The big issue I have with value alignment is that it still begs the question, which values and who's determining the values, right? So it could be, the values that you think are common sense might not be commonsensically right in a different culture. For instance, we're not even talking about bad people, bad actors. We're just talking about different cultures. They might have a different sense of values. So, I mean, it's nice and it's satisfying to talk about value alignment, like, oh, that's all we need to do. We got to align these values. But a lot of the devil's in the details. Which values, who picks them, what exactly do they even mean? Like, for instance, what does a value of non-discrimination mean? Does it mean just to not treat people differently based on their skin or their race or ethnicity or gender or religion? No, I think that's uncritical. That's not good enough. But yeah, it's possibly a piece of the puzzle.
Okay, I can chime in a little bit. So let me give you some examples of AI agents. I'm not sure if even these are considered AI, but I would suppose so. So, there's some serious value alignment problems going on with AI right now. So for instance, when Facebook did all these human behavioral experiments, where they fed people, they changed something slightly about the information that they fed people. They made people happy or they made people sad on a very large scale. It was human experimentation. I'm not sure how many people would agree with, that this is something that, that they would subject themselves to, that they didn't realize that they were being experimented on. They didn't realize how sensitive their mood was to the Facebook feed, but they're still providing data to Facebook. So it's not clear that you would trust the agents who set up these feeds to have their values aligned with your values. As well, there's a lot of people talking about things like facial recognition software. There was an article today that came out about data being collected at the border. It was biometric data, it was people's face scans, and there was a security breach where a contractor uploaded some facial scans of people coming into the country, and those scans got posted on the dark web. There were some hackers who took that data. So there's a lot of levels of trust. You have to trust the people who are designing the AI system. You have to trust them with the design of the system, the handling of the data, and what things you don't expect they're going to do with it after the thing is deployed. So you may have trusted it to do one thing with it, but then after it was deployed, they decided to do another thing with all of that data and with that system. So there's a lot of levels of trust that can really cause serious problems that we haven't thought about.
Wow, those are all very complex issues. I'm becoming more and more pessimistic about whether we'll be able to solve them. There'll be algorithmic solutions to these types of issues. We have a comment from Paul Thompson, a comment and question. First, he says, great presentations. I wonder if it helps to phrase the question in terms of risk, which might be easier to measure or quantify than trust. The risk of using an AI method may depend on the method and how well it's been tested, whether we understand it, but also the risk depends on the user, the context, like in the car analogy. And thanks for the great presentations. This is from Paul Thompson at USC.
Well, let me, if I could jump in and try to take a stab at this too. Yeah, I mean, I think that trust is a risk issue, right? Trust is a subset of risk, but I don't think they're the same thing. You can't blow up. I mean, if anyone's been paying attention to this field, you've seen like dozens and dozens of lists of AI principles come out, right? European Commission has one, Montreal, everyone, IBM has their own list of AI principles. Now, you could collapse all of those into one single dimension, the dimension of risk, but that doesn't help you. That doesn't tell you anything, right? So, I mean, I think the trick here is to unpack what risk means, right? And to differentiate all the distinct strands. There's risk in outcome, there's financial risk, there's risk to future generations, there's risk to character, there's risk related to human rights. I mean, I think risk is an overly broad term, and the goal is to really disentangle all the various lines of risk, to look at them one by one. And trust is a big risk factor. So I think it is correct that trust is a risk factor. It's part of the conversation, but it's not the only risk factor. So it's not the same thing.
Well, can I ask you, and as it relates to Cynthia's presentation, then can trust be considered as understanding the risks? Like Cynthia in her presentation, she said, you know, if you're going to trust the black box, you have to understand all the risks that might affect its.
You know, so this is related. This actually reminds me of another conversation. So I also work in security and defense circles, and there the big concept that people are clinging on to is called meaningful human control. Has everybody heard of this term?
No.
Okay, so, well, this actually is portable to all other areas of AI. So the claim here is that we need meaningful human control over all our AI because ultimately humans are the one responsible. We're not going to punish AI, like we're not going to punish a robot. What are you going to do, unplug it? You're going to beat it, right? So human needs to be in control. But here's the problem that I think a lot of people aren't seeing. Meaningful human control and trust are mutually incompatible. If you have one, you don't need the other. Right? If you have total control, you don't need trust because you got control. You trust only when you do not have control. So think about the examples I gave you. You trust your dog, you trust your kid to do your work. You don't have full control over those, right? So you need to trust them because you don't have control. Now, when we talk about reliability or accuracy or risk of failure, you know, that's I think that's asking, that's similar to asking about meaningful human control. So think again about your kid or your dog. Can you really estimate the probability, the risk probability of your kid not doing your homework? I mean, you can't put a number on it. Maybe you could ballpark, like, oh yeah, 90% sure my kid will do your homework. But that seems to be beside the point of trust. Trust isn't about playing these numbers. It's like, yeah, I'm gonna empower this person with responsibility, or I'm going to leave it to this person to do it. But it is related to, I think, risk probabilities. The risk probability, you know, that of failure needs to be fairly low in order to trust something. But again, I still think they're distinct concepts. There's some issues distinct to trust that you don't get with reliability or risk probability or these other ones. And what we want to do is disentangle all these lines.
Cynthia?
So I like to talk about sort of concrete cases. It's very hard for me to talk about in general. So let's talk about some high stakes decisions. I advocate for interpretable machine learning because I don't trust AI systems. And so having the AI system be a decision aid to a human decision maker seems to me kind of a good deal for both of them, because a human is a black box, and a human can't process a whole database of statistics in their head. So it's kind of useful to have the AI do the hard part, which is like process the data and compute a risk of, criminal recidivism or whatever, the patient having some issue, depending on the setting. And then the human decision maker looking at that risk and adjusting it, or making a decision based on that information that is, that the computer has sort of nicely clumped into this one, set of numbers or whatever it is. So for instance, with judges, you'd have the computer looking at the information about the person and saying, I think that there's a blah, blah, blah percent chance that the person is going to commit a crime before their hearing. And so this is the percent. And the judge could say, oh, okay, thank you for that percentage. I'm going to decide now whether or not the person should be granted bail based on the information in the database, but also the information outside of the database that I have as a human decision maker. And there is no real perfect answer, but I think that combination of the human actually making the decision and the churning of the database coming from machine learning from an AI system is kind of a nice combination.
And if I could add to that real quick, so Cynthia just reminded me of this point. So as I said in my talk, just a risk score or risk number by itself isn't really going to tell you anything. So for instance, go back to this 99% reliability number that I gave in my example. So let's say my laptop is 99% reliable. That's fine for that. If it crashes, I just lose some data. I should have been backing up anyway. But 99% doesn't tell you anything with respect to, say, autonomous cars. Right? It seems like a big number, and like, why wouldn't you trust 99%? But if you think about it, and given all the vehicle miles traveled, right, given all the time on the road, 99% reliability means tens of thousands of deaths, right? So I mean, imagine if I said, look, you have a 99% of surviving your next flight, meaning 1 out of 100 people stepping on this plane is going to die. Would you trust that plane now? Right, so the context matters. The numbers by themselves don't tell you anything, but you need someone to interpret those numbers and tell you in a specific context whether that number makes something more trustworthy or not.
Okay, we have lots of questions are coming in right now. Hopefully we'll have time for them all. Actually, Yolanda typed a question in the chat box, a question for the panelists. Is trust always subjective in the eye of the beholder, depending on the task or context? And can it ever be objectively defined?
So I don't know the answer to that, but I know that even interpretability alone can't be objectively defined. And if interpretability is part of trust, then it therefore can't be objectively defined. Interpretability is it's subjective, and it's also based on the task at hand.
I know it when I see it, kind of thing.
Yeah, it's something like, for this particular task, we think that people will find it more it's by nature, it's something that's human. It's interpretable to a human who's trying to understand it. So yeah, it's generally subjective. Yeah.
Yeah, I agree. And as I said in my talk, trust is very context dependent. It's application specific and it's subjective. It's a social construct, but that doesn't take anything away from it, right? I mean, think about our laws. Think about our names, your name, Cynthia, Kristina, Patrick. Those are subjective and they're socially constructed, but that doesn't take away from its importance. Yeah.
Okay. All right, we have another question from AC. Would you trust to a greater or lesser extent an AI that complained to you about how clumsy the last maintenance technician was that serviced its cooling system? Insert your favorite part of hardware, over an AI that just gave you an unbiased analysis of the last maintenance report? That's an interesting question. So would you trust an AI that basically complained? I guess it had to realize what was important, whether the human failed already. Would you trust it more than unself-aware type of AI?
If you think about, so I presented Honora O'Neill's analysis of trust, right? Trust requires competency, honesty, and reliability. So I think this question speaks to the honesty part. And I think honesty honesty does seem needed. I mean, I would trust better someone who was more forthcoming or honest with their explanations. However, there's also a possibility of being overly honest, right? I mean, so Aristotle said this about all the virtues. It's possible to have too much of a good thing. So think about people who are overly honest, or I mean, I don't know if you heard the expression, mouth in gear. No, I'm sorry, a brain in neutral, mouth in gear. So I mean, someone who's just overly honest and overly sharing. In that case, if you have an AI like that, who's like, you know, bad mouthing accurately people I know, like that doesn't give me any more basis to trust it just because it's more honest. So there is a line. I mean, honesty is related to trust. It's related, you know, according to Nora O'Neill, but it's also possible to be too honest.
Mm-hmm. Anything to add, Cynthia?
I don't understand the question. I am so sorry. I just don't understand what they're trying to get at there.
Well, we can move to, there's many questions, so maybe we should move to the next one.
Right.
When you talk about trusting AI, who are the things that are trusting? Are they the AI experts, or are you talking about the regular person that uses the things that embed AI? And regular people trust things based on a lot of things that don't belong to the real technical domain. So how do we deal with these types of issues? There's a different notion of trust for AI experts versus regular users, end users of the systems.
Yeah, so you may have to design multiple interfaces to the AI system and have it explain its have it explain things differently to different users, and that's also part of interpretability too, because you might explain something different to a loan officer than you would to someone who is subjected to a loan decision. So right now we have serious problems in our justice system because we allow proprietary models to help judges make decisions, and there's an asymmetry in information there where the judge gets a huge amount of information and then makes a quick decision, whereas the person subjected to it actually may not actually get that information because the system is proprietary. And we allow this in our current justice system. And so, you know, if you're subject to that, you may not trust it. And there's a good reason that you wouldn't.
Yeah, and I'm thinking back on what Cynthia said earlier, that there are different layers of trust, meaning that given these people in different roles, they have their own criteria for trust. And I think ultimately what matters is whether the person who has an interest in the system is the one who trusts it. Let me give you an example. So imagine, so Boston Dynamics, you know, makes military robotics and other stuff. They make a robotic pack mule called LS3, or, you know, big version of Big Dog. You've probably seen videos of this. It's meant to carry around supplies and you know, stuff for the military. Now, imagine that this is a totally trustworthy machine, right? Let's say Boston Dynamics has an impeccable reputation. Let's say, you know, the code's been verified and it's been through all these tests. But on a battlefield, when it's actually being used, there's a saying in the military, which is, don't trust the new guy with the ammunition, right? You don't let the new guy carry your important stuff. So even if everyone trusts this robot, if the infantry people don't trust it, that's ultimately what matters to them, because they're the ones using it. They're the ones whose lives are at risk, and there's the ones whose lives could be saved if they only trusted this robot to carry all their heavy stuff. So I mean, it's a good question. Who are we talking about as a truster? I think it depends on whose interest we're talking about. Whose responsibility, whose liability?
Mm-hmm. Mm-hmm. Okay, so along the lines, actually, trade-offs between control and trust, Daniel Schwab has a question. Isn't there a difference between trustworthiness, which is a measure of how much one believes an agent will behave as expected relative to a given action, and trust in itself, which entails taking some action based on the information received, or to delegating this action to an agent to take this action? So trustworthiness versus trusting that it will do the right thing under the given circumstances.
You know, at least in the conceptual or philosophy literature, there's still an open question on what the relationship is between trust and trustworthiness. Is it number one, you trust someone if they are trustworthy, or is it the other way around? Is it that someone is trustworthy if you give them your trust. So I think there's still some, again, I concluded my talk with saying that conceptual clarity is needed on this issue, and that's part of it. What is the relationship between trustworthiness and trust? Which direction does it go in? Or maybe it goes in both directions. This isn't a satisfying answer to the question, but I just want to say that there are layers underneath that question.
Well, maybe pragmatically it might make a difference, or maybe Cynthia has pragmatic kind of take a view on this question.
Oh, my view of this question is I'm reinterpreting it in terms of mathematical language. So I think the first one has to do with prediction quality, and the second one has to do with uncertainty estimation. So in other words, you could make a correct prediction, but be very, very uncertain about it to the point where maybe you shouldn't have made that prediction because you think it could have been wrong. And so there are these real questions about, are we doing correct uncertainty quantification? And uncertainty quantification is all of the field of statistics, essentially. You know, statistics is the field of uncertainty. And if you can estimate uncertainty correctly, then hopefully it will enable the second one. Yeah.
Thank you. That actually helps me to think about this correctly. And all right, we're coming close, but I want to squeeze in some more questions. Could this question by Patrick Stingley, could this question be based on a false premise? One of the earliest examples of learning system was OCR, optical character recognition. Yet even though these are never 100% accurate, who says they aren't trustworthy? Google uses AI algorithms, but who doesn't trust Google? This begs the question, who doesn't trust Google, right?
Well, I don't trust Google. I actually don't use Google. And the reason I don't trust Google is because I don't really like what they do with my information, and because I don't know what they do with it. So I actually use DuckDuckGo because of exactly this issue, because I don't trust them with my data, because all of my internal thoughts end up translating somehow into queries on the internet. And I don't really want a company knowing what I'm thinking. So
just let me ask you, why do you trust DuckDuckGo?
Oh, it doesn't keep track of you. I trust that their business model, which states that they don't keep track of you, is actually honest. Maybe I shouldn't trust that either, but I do. But you know, there's a really big difference between high stakes decisions and low stakes decisions. I mean, for OCR, it's fairly low stakes. You know, maybe an envelope goes to the wrong place and then ends up in the hands of a human who resorts it or something like that. But you know, these OCR systems are, you know, you're judging each letter separately, and so you've got many chances to get most of the letters right, and then generally it does a pretty good job. And again, if the OCR system can't read it, they'll say send it to a human. Yeah, worst case, it goes to the wrong place.
And I guess I might respond to that question by again saying that it seems like a weird thing or a category mistake to say I trust OCR as opposed to I'm relying on it or that OCR is accurate. Now, trust issues might come in when you're talking about the company that's wielding the technology. So Google in this case, I think I'm more trusting in Google than Cynthia is, but I totally get that concern. In which case, when you talk about trust and OCR, it seems to be that you're really talking about a proxy trust about Google, right? So OCR could be 100% reliable, but do you trust the company to use it in a way that is responsible? This might tie back to the earlier question about value alignment, right? So if Google's values are not aligned with your values, that might be a reason not to trust, even if the underlying technology is 100% foolproof and accurate. So again, lots of layers of trust, not just with the technology, but also with its creator and its users and a lot of other stakeholders.
Mm-hmm. We are running short of time. There's still questions. I would like to squeeze in if I have, Yolanda, I don't know if I haven't. Maybe I'll just throw it out. You don't have to answer it right now, but I'd like to get your perspective. So from each of you, kind of Patrick, what do computer scientists are not considering that they should be thinking about when they're building these algorithms? And Cynthia, you know, what should philosophers actually, what kind of clarification would be, what kind of help would you expect from ethics and philosophers to help computer scientists. And, you know, maybe blitzkrieg very, very quickly.
Wow. I mean, I guess I would say this of most people, which is that it'd be better if everyone had more intellectual humility, right? Open to the possibility that they're not seeing everything, they could be wrong, or there's lots of these other perspectives that they're just not aware of. It's especially important for technologists because science and technology have an outsized impact on the world, right? I mean, one coder could affect the world more than what I could do, you know, as a philosopher. So that's why, I mean, it's important for everyone to have intellectual humility, but I think more so for these makers.
Mm-hmm.
Okay, and I'm supposed to, I would have liked to answer his question, but I'll answer the one you asked me.
No, you can answer anything you want.
So I think we have serious problems with the way we keep track of data, the way we store data and whose data it is, especially things like biometric data. We're using data in ways that people whose data it is wouldn't agree to. I think the ethicists should help us out with guiding people not to just use data for everything, you know, be kind of careful.
Very important points. Thank you so much for making them. Wow, this was really, really fascinating discussion. I had a lot of fun. I think other people in the audience also had fun hearing and asking all those questions and hearing from your diverse viewpoints. So thank you so much for participating. And thank you everybody else who asked questions as well.
Thanks, everybody.
Thank you. Thank you, everybody, for participating and for Kristina to organize the panel. This marks the end of the first day of this symposium. Very exciting discussions. I've learned a lot. I hope you all have too. And we'll resume tomorrow. We will start at 8:45 a.m. Pacific time. We will see you there, hopefully. Have a good evening. Bye.